strong entity, so we can create ship relation. What can be the primary key of this relation?
Ship name.
It's a ship name, S name. Okay, and the line, there is a attribute owner. Then next, whether we, so this problem is an obvious case, right? So this is another entity for relation that we can create a relation with the primary keyword. It's a type, right? So type will be a primary key. Then turn it and R. Okay. What is the relationship between the ship and ship type? It's a one-to-many. One-to-many or many-to-one relationship. How can we map the one-to-many relationship into relational database model? It's a step 3. What is a step 3? Step 4. Create foreign key from inside to one side or one side to inside. If you cannot remember, why don't you think about our example?
Yes.
The employee and department. Employee is inside and department is one side. When you create a foreign key from N to what? DN to department number. The target should be the primary key. In this case, this inside is here, so ship has a type. So to differentiate the name, why don't you use S type? Okay? Then this one should refer the primary key of a ship under one time. Okay, that is step 4. If you cannot remember, why don't you check the previous note or the new note? Okay, that is done for this. Okay, then why don't we take care of the ship under one movement? It's a double rectangle. That means, what does double rectangle mean? Weak entity. Weak entity, we can create a relation that is a ship movement with partial key. Since this is a weak entity, it has only the partial key. It's not the full primary key. So, what is the partial key? Anyway, it's a timestamp. However, that is composite key, composite attribute. We cannot create the attribute for composite attribute. Instead, we can use sub-component. That is date and time. Underline. It's not done yet. Who will take it? The other attributes include longitude and latitude. What about the primary key? How can we make the partial key as the primary key? We need to use identifying relationship. That is a double diamond history. So just think about it. Ship movement. So we'd like to keep track of the movement of the ship. So we know the time stamp, date and time. But at the same time, there are a lot of ships that is moving, that are moving. So we should know ship name. Okay? So that is can be borrowed from the ship, primary key of the ship, so we can use the ship as the primary key. Is that all? No, this should depends on what?
Timestamp.
Timestamp?
No.
So from that's name. Okay? So what is the primary key of a ship under a movement? Ship name. So why don't we use the similar name as the primary key? Then we can use it as name. Ship name, date, and time. This is the composite primary key of ship under one movement. That is done up to here. Okay? Then next, why don't we take care of code? Before that, state on slash country, because it's a strong entity. So state country. Create a relation for this, and primary key is what? Name. But to differentiate from other name, we are going to use SC under one name. This is the primary key. Then other attributes continue. Similarly, sea, ocean, lake will be one relation. What is a primary key name of it? To differentiate from other name, SOL name is the primary key. Okay? We do not have other attributes. So primary key only. So far, so good. Then next, port. Is it strong entity or weak entity? Weak entity. So which means it doesn't have primary key, but it has only part of key, that is key name. In other words, let me explain the situation. Port. The Bridgeport. We have Bridgeport. Who knows? Another Bridgeport in California. Okay? Same port name, but different location. So using port name, we cannot identify specific port. Which means, which one we can use for identifying the port name? This one or this one? In. Okay, why? It's a double diamond. Double diamond means it's identifying relationship. Okay? Somebody may be curious, why can we use this? It's a double diamond too. This is identifying relationship for this because it's a double line over here. This is the partial participant. So we can use this identifying relationship to make the port have the primary key. And then port will be this one. Okay, then we have only part of the key, that is the key name, port name. Any other attribute? No, we do not have. So to make primary key, so we can borrow the key of this one. This is SC name. You can use the different name from this, but in this case I use the same name as this. So we have only one primary key, but it's a composite. And this SC name should depend on SC name in state, country. Okay? Then that's done up to here. And what about this one?
Yeah, why?
What is this? It's just n to many. One to many or many to one relation. Step 5. Okay? Step 5. 1, 2, 3. Step 4. Just like this. One to many. How can we have? We can create the foreign key from n side. From here. Port. Okay? Port has the information about the sea, ocean, lake. So port, from the port, sea, ocean, lake, that means SOL name. Create the foreign key. Okay? Can you understand the meaning of this? Where this port belongs to? Atlantic Ocean. Facing Atlantic Ocean. Or in Atlantic Ocean, there are many ports. So many to one relationship. So we need to specify the SOL name. There might be more information about the size and the temperature and the average tide, height of the tide, and so on. But this is the simplified one. So this is done up to here, except this part. We can solve this problem many to one, home port relationship, right? So many to one, so we can create the foreign key from many to one side. So ship, where is the ship? Ship is here. So what is the primary key of this? Primary key is SC name plus key name. this is the composite. Okay? That is different from what we have learned so far. So far we have discussed on single attribute foreign key. However, composite foreign key are also available. So to indicate the composite primary foreign key, I'd like to use the parenthesis. Not always, but this one is easy to understand, the composite. Then refer the primary key of port. Okay, SC under my name plus port name should exist in the port information. That is this one. And in the port there are many children ships. Okay, so that is the meaning of this one. Yes.
Should add the location name of the sea ocean here.
Here, see?
Yes.
Location name?
Yeah. Of the sea and ocean, the name for the port. Port. That's what. Yes. Here.
That is this one. SOL name. SOL name is in the S state, the sea, ocean, lake. This is the primary key.
So we should add the continent name.
Continent belongs to state and country. That is belongs to here. It's a different entities.
No, to the port. I mean,
Port.
port.
Why do we need to add a continent to the port? This belongs to state and country. If you want to know the name of a continent, you can find from port using what? From port, you have the SC name. SC name is here, then you can find the continent name. Okay? Any questions so far? So this is the one thing you need to use. It's a composite foreign key. In real life system, the composite foreign key are not very popular. Yes, doable but not popular. Instead, we are going to use surrogate key, the substitute key for this one, like the port ID. You can create the unique number. Not only because this is complicated, but also because fast. So sometimes you have the 5 attribute, 6 attribute for primary key. Instead, we'd better use one number. Okay, port ID 1 you can create. Then at the time you can use the port ID from this to this. Then it can be single attribute foreign key. However, in this case, to keep the meaning of this one, we are going to use the composite foreign key. Okay? That doesn't mean this one refer this one. This one refer this one. No, you don't have to create the 2 foreign key here. Instead, 1 foreign key, but composite. That's totally different. Okay? Any questions so far?
Yeah.
Yes.
In the port relation, can we take the primary key from the ship relation?
Or
Because it's
ship? No, this is just the normal many-to-one relationship.
Yeah, but
This is not the identifying relationship.
yeah, but you told us that we can take from the relation any relation you want.
No any relation. So here, so in this case, the 2 key, we need to convert the meaning of this one. Right? Relationship.
Another relation.
This one,
Yeah.
this is a total different. They are not the same. For example, employee and department, how many relationships do you have? 2. One is works on. Another one is manager. They are totally different one. Okay? In this case, it's the same. We have 2 relationships. Especially this one is for what? Identifying relationship. Even that is also ternary relationship. Okay, who will see?
Professor,
Yes.
isn't that port weak entity?
Yes, it's a weak entity. So that is the reason we borrow the key of this. So port is the SC name. This is the SC name. I changed the name to SC name. Okay? to differentiate from this one. Okay, so this is a SC name plus P name will be primary key of port. Yes.
Sir, about the composite key, like we can substitute two or three attributes with one attribute, and we can call type port ID.
Yes, that's what I'm saying.
And it should be like taking a unique number one.
It should be unique.
Okay.
Okay, but even though you are using the additional key for port,
Yes.
that is port ID, you need to keep this information.
Of course.
Okay? But if you do not understand such a surrogate key, forget about it. Okay, we will take care later. So you can just use a composite foreign key over here.
What is the name of this process? Composite?
Surrogate key. Surrogate means, what does that mean? Surrogate. It's a substitute. You can
Surrogate.
change. Yes, surrogate.
Can you?
It's a surrogate. I'm not sure whether double R or single R, surrogate key. Okay? It's a substitute. You can change. Okay? So that is up to, did I do this one? Ship. From ship, yes. So the only remainder is this part. Visit. So visit is a weak entity. So we can create the visit. What is the key of the partial key on your start date? This is a partial key, not done yet. And end date is attribute. To identify the specific visit, you should know what? Key of identifying relationship. What is the identifying the entities? One is a ship, another one is port. You should know two of them. In other words, for example, so I'd like to find the specific visit to the port. Okay? To find the visit, I know the date. Okay? But at the same date, there are many other ships, right? So we should know the ship name, who visit. Also, there might be the multiple ship. They are the same. They are sharing the same name. So, for example, Virginia. Actually, this one is from Bridgeport. And another Virginia. This one from the San Francisco. Okay? So, to identify the specific visit, you should know ship name as well as the port name according to this ER diagram. Okay? Then, which means, what is the key of ship? It's the S name. This one should be in this. Then, what is the key of port? Port is SC name. And this one is P name. Okay? Yes. Then, this one should for this one. So how many attributes? 1, 2, 3, 4 attributes. Composite primary key in this visit. In other words, to identify the specific visit, you should know this one, this one, this one, and this one. That's all. That's it. Any question? Yes.
How come we know port is weak entity for
How?
ocean?
Because this is a double rectangle.
Yeah, not for
Then?
the ship. Not for the ship.
But
entity.
this is a double
Okay.
diamond and connected by double line. Double. What does that double line mean?
Total.
It's a total participation. But this is a single line, which means it's optional. To identify certain data, you must know. It's mandatory, which means this one should be used for identifying relationship. Then this is the identified entity. For primary key, so we will get the primary key of this one to here. Then we have seed name. This is a primary key. In addition, to identify the visit, you should have the identifying relationship. So, how many? 2 of them. So, get this key, SC name plus P name plus ship name. So, total 1, 2, 3, 4 attribute for one primary key. It's the same thing. If you want, you can make it visiting ID, sequence number, to make the composite primary key simpler and simpler. Okay? Any other question? It's not easy. Also, I'm going to upload the answer key. Answer key even is not correct. So it's done by my previous GA. I thought she was correct, but when I took a look at the answer, it's wrong. But many of the students actually they use this answer when they submit it. Okay, so this one. It's not absolutely wrong, but some of them are a little bit complicated. Okay, any other questions? So the next question is for vehicle. Okay, vehicle. We have the special one, super and subclasses. Vehicle, 2, car, truck, SUV. I asked you to map only the super and subclasses. But some of you guys already did for salesperson and customer. It's not a big deal. First, we can use the 4 different options. The first option is what? One relation for each class. In other words, how many relations can we create for vehicle, car, truck, and SUV? How many? 4. So you can create the one relation for vehicle with primary key VIN, and another relation for car with primary key VIN. Then create foreign key from car to vehicle VIN. Similarly truck, similarly SUV. So you can do the first option. Second option, how many relations can you create? 3, 4, car, truck, and SUV. What is the primary key of car? VIN. Okay, then what is the attribute? Price, model, and engine size. What about truck? What is the primary key of a truck relation? VIN. What is the attribute? Price, model, and tonnage. Similarly, SUV. Do we need any foreign key? No. In this case, we don't need the foreign key. That is the disadvantage of using the option 2. Then, the third option, how many relations? One relation for vehicle. So vehicle ID will be primary key, price, model. Then what do you need?
Price.
Type of vehicle, vehicle type. Then engine size, tonnage, and number of seat as the attribute. But that's good for what? This joint case. Option 4 is similar. You can create one relation. Vehicle, VIN is the primary key, then price, model. Then you need to create, is it car or no? Okay, so car, yes or no. Or car, YN. Car, flag is a 0 or 1. So you can use whatever you want. But if you name just a car, probably I cannot understand whether this is a yes or no, true or false, or flag. Okay? Eventually, when you create the real database, you will select the specific data type, like the integer, character, or whatever. At that time, you need to select Boolean type. Okay? So, as long as I can understand the meaning of that attribute, YN, or yes or no, or flag, it's okay. However, if you just name car, Nobody know, nobody understand the meaning of that. So yes or no, or YN. Then engine size, truck, yes or no. Tonnage, SUV, yes or no. Then after you select one of the options for vehicle, car, truck, and SUV, the next step should be ternary relationship. To address the ternary relationship, we can create one command, one relation for sale in this case. Okay, sale, then salesperson will be another relation, customer will be another relation. Then what is the key of sale? It's all the combination of the other, the relation like the VIN plus SID for salesperson, SSF for customer will be key, the primary key of sale. Then date will be attribute of it. That's it. So that is the next question. In your midterm exam, probably I'm going to use a lot of your class activity, like the classroom project and the classroom example or quiz or homework. Okay? At that time, I'm going to slightly change it, very slightly change it. Okay? So like adding the one more subclass. So it's not huge difference. Even sometimes I copy and paste from quiz. But the problem is that your average score is less than half, less than 50%. So please try to understand. So even though I ask you to complete only the option for this, but you should practice the other ternary relationship part. Also, we already saw the very complicated one, person. If you can understand the person database, probably this may be the piece of cake to solve the problem. Okay, then after we have finally we have the initial first version of relational database schema model. Okay, like for example, this one. This is our initial model. But as I mentioned several times, depending on the requirement, sometimes depending on the person, there is no general answer of the relational schema diagram. Sometimes it can be combined, sometimes depending on your selection of the option. You may have one relation, sometimes you may have two relations, you may have the many relations. Who is correct, who is wrong? No, we don't know. It depends sometimes. Sometimes all of them are correct. But the only difference will be performance, or sometimes how much easy to maintain the data. So after you got the initial or draft version of relational database model, we need to decide whether this is good enough, good model, or is there anything should be modified or enhanced. You need to decide. The chapter 15, in this chapter we are going to discuss about how good our initial model is, or how we can improve the quality of our database model. So to discuss about it, first we need to decide what does that mean, good or goodness in terms of database. Good is good, it's better than the other, it's not bad. But what does that mean in terms of the database model? Let me change the question. So somebody model this is a company database like this. Okay, this is the output of relational model. But me, I create one big relation company. It has all the information about social security number, e-name, and whatever. And d-name, d-number, whatever. And d-number, d-location, and everything in this. That primary key is the combination of each primary key. Then it can be one model. Do you think which one is better? My modeling and your modeling? This one, number one or number two?
Number 2.
Number two, number one, mine. Nobody likes me. Number two. Yes, that's true. Then how did you decide this is better than this? What is your criteria? Yes.
You have to repeat every single entry in every instance. For example, for each employee, you have to repeat the same information that the input for the department.
Mm-hmm.
You have to put all the information for the department. You have to repeat all the information.
Can you understand what he is saying? For example, so we have the 100 employees. So we have the 100 employees for HR department. How many times do I need to repeat it? Write down this. 100 times. Actually, all of them are the same.
Yes.
But so one time is enough. Here, HR department, but here you need to repeat. It's a redundant information. The data are duplicate, redundant. Actually, that is the most important thing when you model. The database guys, database system, database programmer, database model really hate any redundant information. Why? Yes.
Because sometimes you can enter in another instance, you might be wrong with I or E, and the queries won't distinguish that in the search or queries.
And performance?
I
I don't think so. In terms of performance, sometimes
you have to
this one is better than this one. Let me explain later. Okay? Yes. Cost. In terms of space.
Waste.
So waste of your space. Let's say that we have 1 million employees for one project. Whether or not that's true. We should have 1 million. It's a waste of your space. Okay? Then anything else? Yes.
difficulty in the update.
Difficulty in updating. For example, HR moved to New York to LA. You should update all of them. Right? Yes.
Professor, let me explain my idea.
Yes.
I am a data entry, okay?
Huh?
When I'm writing for the 10th or 100th employee, I just write HRI by accident. And then you want to query how many employees are there in
Can you
the
understand why?
department.
What
This is
he
more
saying?
important than space nowadays. Space
For
is
example,
neglected.
so in this
You
case,
receive.
so we have the 1 million employees. So I type the 1 million information about it. And accidentally, I write down HRI.
Accident?
It will be accepted. Right? Even though name is different, it doesn't matter. Because as long as it keeps the primary key constraint. Right? Because we do not have the foreign key. So very hard to keep the consistency. Okay? So that is the reason we select this one. Any other? Simply, which one will be easier to understand? This one or this one? To identify you should take a look at and make the group. This is for employees. So this one is much easier. Okay? And anything else? Also, not only the duplicate data sometimes. So this employee does not work for any project. Which means this one should be none. There are so many values that should be none. Okay, for example, the HR department does not have some other information. If we have some other information for this, This one should be all null data. Something like that. So sometimes there are a lot of null data. That means it's a waste of space. Somebody may be curious, why null keep the space? Professor Lee said, null is nothing, not existing. Not existing means our human idea. In terms of computer should use a certain space to indicate null data, not existing. You understand what I'm saying? Okay? Even though null means nothing exists, the computer cannot understand what is null, nothing, existing, or not existing. They should use a certain 0 or 1 value to indicate this is null, this is existing, not null. Something like that. So, in case you have the one big relation, you may not. Sometimes you may have the waste of your space because of null. Okay? Any other reason?
When you do updates, huge updates,
Yes, another problem is we already did update. Right? You need to update all of them. Yes.
Maybe conflict data.
Yes, complete. It's complicated. So hard to understand. We already discussed. What about delete the data? So the business is not going well, so we decide to remove the one of the department, downsizing the company. So HR, we don't need HR. Okay. Then if we delete HR information, what about employee who works for this? We need to fire automatically? No way. In this case, we need to fire, delete all of the data. Also project too. So sometimes, even though we do not want to delete the other data, because of the bad modeling, you need to delete the other data too. Okay? Similarly, inserting. So we decide our business is going well. So we decide, the company decide to create administrator department. However, can you insert the data here? You should have the employee. You should have the project. You should have the work zone. You should have all the data because primary key. Very complicated composite primary key. You cannot insert a new department. You cannot insert it because of the bad of this. So that is the guideline. That is the criteria when you decide whether this is good enough, good quality of the modeling or bad quality of the modeling. If you decide this is bad, it's not good, we need to do something. There are two ways. One is informal way. Another one is a formal way. So informal way, like our discussion just before, we are going to use something descriptive language to analyze the initial modeling. So whether this is good, so whether this one has any problem when we delete or whatever. So we are going to find first guideline, second guideline, third guideline, and fourth guideline. So according to that guidelines, so we judge the goodness of the modeling, then do something. We will learn what can we do later. And that's the first approach. That's called the informal way. Then another one is called formal way. What does the formal mean?
Depend on the system or something.
One word.
Mathematics.
Mathematics. So we are going to use the mathematics. In the first approach, we use descriptive language, informal way. Okay? But in the second approach, we are going to use mathematical way. Especially, we are going to use a functional dependency. Function. Have you ever learned about the function? Yes, definitely. So from the elementary school or junior high school, you learned about a function. So we are going to use such a function to make our initial modeling better and better. Okay, that is called the normalization. So have you ever heard about the normalization? One? Only one? Doesn't matter, so we will learn. So normalization means, what does normalize mean? Normalizing. You probably know the normalizing. Make a simple or make a standard. So it's the same thing in the database model. Normalization means we are going to segment. We are going to make the relation simpler and simpler. So sometimes it's called the segmentation. Segment means divide into several pieces, smaller pieces. Okay? So if we here using normal way, that is called the functional dependency. Function, if we find any evidence this is not good, cut. Segment. That is called normalization. It's a formal way. So two main approaches. One is an informal way, another one. Informal way, we already discussed 90% of the informal guideline. You already know. And second approach is the formal way. It's called the normalization. Normalization, there are steps. First step is first normalization. What will be the second step? Second normalization. What about the third one? Third normalization. What about the fourth one? Not fourth normalization. There is another one. It's called the post-code normalization, BCNF. The next level is fourth normalization. Next, fifth normalization. Fourth normalization actually deal with multi-valued one. The fifth normalization is a joint dependency, but we are not going to cover these two. Higher level normalization. Instead, we are going to cover 1, 2, 3, and post-code normalization. The good news is when Dr. E.F. Code proposed a relational database model, he tried to use the very fundamental of the mathematics, which will be easy to adapt it in our database model. So he tried to use the human beings or your normal life, so or normal thinking process. The good news is if you have the common sense, okay. Also, even though you do not have the computer science knowledge, everybody can do up to third normalization automatically. That means, so if I ask, why don't you manage your university database, university data, then probably you will collect student information. Without understanding the complicated modeling technique, probably you will collect entire student. This is for instructor, this is for course, this is the grading. Everybody can do that. That is a third normalization automatically. Then BCNF is a little bit exceptional case. Then that's it. Most of case, 95 to 98% of the modeling can be done automatically up to third normalization, which means we don't have to learn this kind of thing so far. Pretty much everybody can do up to third normalization very, very easily. The problem is in real life system, sometimes there are 2 to 5% of complicated, non-obvious case. To address those problems, you should know the ER modeling, relational model, and normalization process. Also, very rarely, there are complicated cases like the fourth normalization, or fifth normalization. Those will be discussed in advanced database course. Okay, so we are going to discuss first, second, third, and BCNF in the next class. Today, we are going to discuss about the formal, informal way. Then, one more thing. Somebody mentioned about the performance. But this one and this one. So, I'd like to access the employee name as well as department name. If you have this database and this database, which one will be faster? This one? First one? Why?
It's like an entity type. You can search all the data in a single row instead of both.
Can you understand what he is saying?
Yes.
So, for example, let's say, so I have two sections of the database. Okay, so morning and afternoon. I have announcement. How many times do I need to announce? 2 times. But if I have the combined class, how many times? Just 1 time. 1 time is easier, right? Faster. So if you are not in the classroom, I need to call, email everyone. It takes a longer time. That's the exactly same thing. When I access the data from multiple relation, multiple data, it takes longer time. How can you find the department information? Using D number. Okay? Using D number, you can find the data. For example, here, John Smith. What is the department number of John Smith? Department name. Which department John Smith is working?
Research.
Research. How can you find? You cannot find the research over here. Only 5. Then using the 5, you can find the name of department. That is called join operation. You can join. When you combine 2 or more relation into 1 to get the data, you can combine using what? Foreign key. Okay? Foreign key relationship you can combine into 1. That is called join operation, which is a very, very useful but very expensive operation. What does it mean expensive in terms of computer? It takes longer time. So that is the reason it's not always true. This one is bad in terms of performance. Sometimes it's faster. That will be discussed at the end of this chapter. That's called the denormalization. Denormalization means we are going to merge the smaller. You already did everything, but when you feel performance is the critical, so you can combine. So reverse way. So that is called the denormalization. Denormalization is frequently happen in real life system. When you test your system query and application, if you feel system is slow because too much segmented, too details normalized. That time you can go back, merge. Even though you lose some benefit of such a normalization, so you can go back because performance is the issue. The first class I mentioned about why we use the database. First reason, accessing data fast. If that is slow, just throw away. So you need to think about the performance. But here we are going to discuss about first, guideline. We already discussed. Each relation should have 1 meaning. That's it. Then it's simple, easy to understand. It's better than this one. Can you understand the meaning of this? Very hard to find. So it has the employee information, department information, project information, work zone information. However, if you take a look at this one, so this one has employee, this one has department, this one has department location, this one has project, and this one has work zone. It's easily you can understand the meaning of each relation. So first guideline is each relation has 1 meaning, 1 semantic. What if you have the 2 meanings in the same relation? What can you do? Two meanings. For example, employee underbar project. Employee number, project number, email, project name, number of hours. How many meanings can you find here? It has employee information, right?
Project.
It has project information.
5.
So it's
5 minutes.
5 meanings?
2.
Employee and project.
So 6.
Actually, one more. Work number of hours is not project, is not employee, it's a work zone information. So actually 3 different meanings. then what can you do when you find this one? So you decide this is not good enough, not a good quality of the modeling. Then what can you do? Separate. Solution is always the same. Separate, segment. That is a benefit. That is a way of relational modeling. So you can segment whenever you want. If there are more than one meaning, okay? So in this case, you can take up employee and e-name. You can take up the project and project name. You can take up employee number plus project number plus number of hours. That is the solution. So first guideline is one relation, one meaning. That is the first solution. The next one is, this is the one example, employee underbar project. Okay. Then, why don't you take a look at this one. So in this case, we have 1 million employees and one department. So when you update the department information, how many times do you need to update? 1 million times. So waste of time. Okay? Also very dangerous in terms of integrity. So who knows? I'm very tired. So in HR1, HR2, so it can be accidentally different name. So that is called updating anomaly. It's a wicked thing. It's not usual thing. It's an unusual thing will be happen when if your model is does not have good quality. Based on what? We already discussed it before, first time. So that is the updating anomaly. Also, it's the same thing, delete. When you delete the HR information, the other meaning will be deleted. You actually didn't expect the employee data will be deleted. No. Because one, it's a bad model, bad quality. It's not good quality of the model. So data will be unexpected, accidentally deleted. That is called the delete anomaly. Delete the unusual thing. Also, insert is the same. We already discussed. So we have the new department, but it cannot be inserted until it has this one, this one, this one, this one. You need to find those data. That is called the insert anomaly. So, second guideline is no insert anomaly, no delete anomaly, no updating anomaly. Okay? Can you understand these three anomalies? So think about a very simple case. Yeah? If your modeling is good enough like this, there will not be no problem when you delete, when you insert, when you update the data. It will be working as you expect. However, if your model is not good enough like this, when you delete the data, department, employee will be deleted. You cannot insert the department without employee. You may update more than one time of the data. Those are caused by what? Bad quality of your data.